Before we begin using the image maps that were rendered earlier, I want to show another method of getting the altitude, slope, or whichever maps you need to generate from geometry out into an image that's going to be usable. This way you don't have to crop anything, you don't have to set up any cameras, and it can go a lot quicker. It will really just depend on the situation and the object and whether or not the UV map is set up correctly for it. In this case, this was originally created from a plane, so the UV map is set up evenly. If we take a look, it's a very tight grid. Looking at it from here, you zoom in, and there's no distortion of that map. So what we can do is right-click on the object, Cinema 4D tag, Bake Texture. I'm going to use and match to the object, which is 600 by 600 pixels. So that way each pixel is going to be a proper amount of altitude. Save this, we could do 16-bit, 32-bit if you need to go really high with altitude, but for the most part, the 16-bit will be more than you need. So then you can choose the file. We'll just call it altitude bake, and we're going to go over to the options, and we do have this running, the altitude on the luminance channel, so we can just turn on luminance. And if we go ahead and preview it, we're going to see a nice preview of that. If you do want to have what would be basically anti-aliasing, you can go over to the tag properties and set up super sampling. In this case, it's not something we would want or need to do because we do want it to match the geometry. If we were to increase the geometry, then we would really just increase the texture size. But for more complex textures, then you would want to have super sampling. Once you're ready, then you can go ahead and bake it. It's going to render out this really quickly. And now we don't need to worry about cropping it out. So here is that map, sized perfectly, and we can see all the altitude information. And this is going to match the polygons, keeping in mind that the polygons themselves can be angled, so that we're really trying to represent the polygon's center and its height. If you do need to go a bit further, or if you're having any trouble assigning objects to this range, and you need to increase the altitude range per polygon, what you can do is increase the size of the render output. Obviously that rendered very quickly. It's really a matter of just the scale of the image itself, or the size, the file size. But this is only 2 megabytes for 16-bit, so we could double it to 1200 or go even higher, maybe put 2400 to get more detail. So this is a situation in this case where that's going to be the desired method, but if you don't have that ability because of a UV map setup, and if you don't have the ability to really set up a different type of texture mapping in order to fit, the top camera method does work, along with the multipass if needed. Now we're going to take a look at using the images we created from the dirt object, the altitude and the slope, and creating new ecosystems using those controls. I am doing this in a different scene, without the objects in it, just for the ease and the speed, because I am recording. With Carbon Scatter, merging scenes together, I'm not quite sure how reliable that is. So this is typically something you would want to do within your main scene, unless you were just kind of testing things out and maybe creating functions that you could save. In this case, we could set everything up in here and save out any functions we create and then load them into the other scene. So technically, there are ways to separate it. So what we're going to do is create our object to populate the gravel. I do have the rocks in here, and I also created a sphere that is about equal to the size of the rocks, just as kind of a dummy object, just for speed, and be able to see things a little bit quicker. So what I'm going to do is add in a plane, and we're going to set that to 17 meters by 17 meters, which is the same size as the dirt object. We can set our width and height segments, so I'm just going to use 2, so that we're going to have 4 polygons. And if we take a look in the right view, our plane is going to be starting at 0 on the Y for the position. Of course, it is all centered. You will want to match things up. So what we're going to do is select that plane, and I'm going to go ahead and add a .cs after it, so we know that it is going to have a Carbon Scatter ecosystem on it. So now what we can do is populate the object, and we're going to set our mapping mode to world, standard, and add in our native object, which is just going to be that sphere. And if we populate, we shouldn't really see anything. It is going to tell me that it's going to take a lot of memory to populate the ecosystem because these objects are so small. It actually went really quickly because the polygon count is so low. Of course, we're not seeing all of those objects. And if we go ahead and render it, just taking a look, we can see massive amounts of these spheres. Render time is very quick. However, in this case, that low polygon count that was showing in the preview is not being applied. It is a render perfect sphere. So it is going to end up using a little more memory. During the render, it shot up to about 4 gigs of RAM for this population. Okay, so let's go to that plane, and obviously we're going to set up our density and reduce some of these settings. So go back to the populate. We're going to go to the density, set it to a variable. I'm going to go ahead and clear this ecosystem for now. Edit the function. We're going to add in projected texture map, setting the mapping mode to flat vertical, and loading in our texture. And click OK and populate, and just take a look and make sure everything's lined up. It doesn't look like it is applying that properly. So let's try an unscaled projected texture map, flat vertical. And that should fit to the object. So if you're working in the world standard mode or any of the non-parametric mapping modes, the unscaled projected texture map allows you to use world-based nodes for scales of fractals and noises, but allows you to take your texture map and still make that parametric. So that is pretty nice. So that's showing up we can see it. What we want to do is offset it now with our altitude map. What I want to do is change my display quality. We can show the geometry. And I might remove that dirt texture just for the moment, and that way we can see the objects better. So go back to the plane, populate, and we're going to load in a map to control our absolute offset from the surface. Now, one thing I didn't do is move the object axis for the sphere to the bottom, because it's not a baked polygon geometry, but all of the rocks do have centered axes, so that does match up correctly. So what we want to take a look at is the absolute offset from the surface. What we're going to need is that number that we used in the material, which I still have in the scene. So we can select the altitude, take a look at the gradient, and 0.022 meters. So we'll just type that in. And just see if it's going to offset it correctly. And it should be around to the top of the object. And it doesn't look like I'm seeing the instances in the side view. So we'll go to our front view where you can see them. And it does look like they are offset to the top. And it does also look like it is using the axis center, or the bottom of the object, rather than the axis center, to position it. So we might need to compensate for that. I'm going to set it back to 0 really quick and populate and just see how these lower. Okay, so normally we would have it using the object axis. It is using the bottom of the object automatically. So we'll just keep that in mind, that it might be different with the rocks. And that's just a very small subtraction within the altitude conversion. So I'm going to just extract this 0, drive with the function, and just make sure that it is going to show up 0 in the function editor, and it is. So we can clear that out, type in that 0.022 meters to find our number, which is going to be a little bit different within the function editor. We have 0.00022. It is set to parametric, which is why that is showing up that way. If I populate it again, I just want to make sure that it's going to return the same number, because I might need to change to a different mode. But parametric is working properly, so we'll use that. And what we're going to do is set up another constant node of 0, add in our blender. So a combiner node set to blender. Input 0 is going to be connected to that constant node of 0, constant number 0. Input 1 is going to be that constant we extracted. We can replace the link for the offset to the blender and now load in the image. Since we want our scales and everything to be the same as this other unscaled projected texture map. We can select that, just click off of it, red box, create a new texture map. It'll duplicate the previous one. Copy and paste in carbon scatter is doesn't always work. So this way you can just create a duplicate that way. If you do need to copy and paste something and the copy paste commands aren't working, you can create a meta node by selecting multiple nodes. And if you only want one node, you can just add maybe a constant node that's not connected to anything and select that with it. Create a meta node from the selection, and then you could save that out and load it in later. And that'll include texture information and everything within the meta node. So I'm just going to ungroup that. We're going to change this and load in the altitude map. And what we're going to need to do before the output of the unscaled projected texture map or the altitude reaches the blender is just constrain it, because right now what we have, and it is not going all the way up to 1, because when I rendered the texture I was in the linear document mode. And so the linear workflow was checked when I rendered. So it did constrain the white when I saved it. So the actual full output is 0.75, it looks like, for the top. So we might need to just change it and map that a little differently. But we do need to restrict this image to be within 0 to 1 instead of what would typically be -1 to 1 for the black and white. So add in a filter to that link. We're just going to change it to the map. And it did disconnect. Sometimes it will disconnect from textures, so we'll just reconnect that. If you change the type of the filter, sometimes that can happen. So right now we have it going to 0 to 1, which is not going to be the full range of the offset because we need that 0.75. So let's go ahead and type in 0.75 for the upper value. And as long as the extension doesn't go higher than 1, you know that your value is correct. So if I set this to 0.6, the automatic extension, if that's checked, the extension amount has now changed to 1,086,118. It's higher than 1, and it gives you the value of how much it is higher. So that gives you a better idea how you can clip things out. 0.75 should be good. If you want to start bringing it down lower and lower to get it as exact, right now I just went over when I went to 7.2. So now I can add a 5 to it. That's not quite high enough. 8, bring it up to 3, and 0.73 is a lot closer. We haven't gone over 1, so therefore our top part is around 0.73, and that's pretty close. So now we can click OK, populate, and now we'll have it conforming to the altitude of the terrain by using a plane without the actual geometry. So that's really going to speed up population time and allow you to use a lot more instances. It should also save or reduce file saving time as well. So now we can see once we render, we are going above the object, and we don't have it intersecting because it is resting on top. Now I do actually want these rocks maybe to go through a little bit. So what we can do is add in a little bit more to the function in order to offset the size. Now we can't go too much because the way the scaling is set up, we can end up with a lot of objects that are just going to be not seen. So if we go back to populate, knowing what our maximum amount is, which is 0.00022, we can offset this or subtract. Offset filter is going to probably work the best. So add a filter, change it over to the offset, and then we can select this bottom offset output node, add another filter, and it'll add it to the chain. And what we want to offset it by is a negative 0.0001, and we'll just take a look at that. That might be a little high, but we should be able to see them going through a little bit more. And that looks like it is just about half. But we still have our altitude overall being controlled properly. I am going to actually go back really quick and reduce the density. Nice quick ecosystem populations, which is why this method is really nice, rather than using the geometry. It also keeps you from baking objects that don't need to be baked. So now that's looking a lot better. And you can still see that the smaller objects are only going through about halfway, so we're not really losing much of anything. And this is with a setup for no change, no scale variation, and slightly lower density. But nice conforming to the terrain. And obviously we're zoomed in really close. If we want to take a look at it from farther away, we can just move the camera out and take a look. So now if we wanted to also control the slope distribution, because we're populating on a flat plane, the presence options, or all the options under presence, with the exception to orientation, and even that might be a little bit off, these aren't really going to help you because we're on a flat object. We have to use the images in order to control these settings. So if we want to control, let's say we only want to have the rocks or the objects created on the steeper slopes. What we can do is mix together with the density our slope object. So we're going to add, or a slope image, so we're going to add another texture map. I'm going to load in the slope. And the easiest way to mix this would be to add a constant node, setting a constant number of 0, or actually -1, because -1 is going to be no density. And what we're going to do is add in a combiner node. I'm having a little bit of an issue here adding or clicking. Oh no, it seems to be working. Okay, so I'm going to add a combiner node set to Blender and set input 0, which is going to be, because what we're going to do is use this density to control this. So that's going to be the black. So we want that to be -1. And then 1 is going to be our grayscale output of this. And if we might need to clip these values a little bit, or increase the contrast of the image. We'll just take a look at the turnout first. Now we can control the ratio of the blender, so making sure that the show parameter connections is turned on, so that way we can grab that side output, or what we can do is just extract the ratio and change the connection. So what we need is a ratio between 0 to 1. Because this information is just black and white, we don't have grayscale and no in-between amounts, so we don't need to map it. What we can do is just select clip ratio 0 to 1, which is automatically going to just cut out the black and make it a medium gray. Connect our density output to that. Click OK. Populate. And now we'll have objects only showing on these steeper slopes that we were able to render out from that image. If we want to, say, reverse this, what we can do is just a very quick change using the unscaled projected texture map that's controlling the ratio. There's a little button here above the Y. The Y is to control the gamma. I believe the system gamma might be set to 1.8. You can override it if needed. This isn't grayscale, so it shouldn't be a problem. But what we can do is just invert, which is the little button just above that, which is going to change our output, and that way we can produce the exact opposite of what we just have. So now we're going to have it populating on steeper slopes. And actually, I did invert the wrong image. Our distribution is going to be the same. It's the slope map that does need to be inverted. So repopulate that. And so now we'll just have objects showing on just steep slopes. If the population or the density is too high for the overall density, it might not be that visible. You can kind of see that there are less. You can see a few strips here and there along the steeper areas where it's not showing. I mean, there's only so much area to work with because the geometry is not very complex for the object. But what I could do to show that a little bit better is just reduce the density a little bit more. And now we can see a lot better that the steeper areas really aren't part of the population. We could clip that out if needed and cut it, modify the image a little bit more to reduce it. Another thing we could do for that slope, I just want to show one last thing with this setup, is instead of controlling the density, we can control scaling. So we're going to keep that density set to the unscaled projected texture map, so we're within those bounds still. And what we're going to do is within the function editor, we're going to control our scale using the map that we have for the slope. I'm also going to just override the gamma to 1, and that should make sure that the grayscale isn't modified at all. It might even have to do that with the altitude, because like I said, I do believe it is possible that the system gamma is going to be 1.8, just because this is based off of Vue's function editor version 9, and in version 9 that default gamma is 1.8, so it looks like that's kind of being carried over into this, so that can modify your images, changing that gamma. So I'm just going to override them to 1. The gamma source, the image itself is 1.8, but we do want a linear control in this case, so it's a little easier to work with. So the scaling, I'm going to set it up so the black is the slope, and that way we're going to have smaller objects on steeper slopes. So going into back to the material editor, we do need to turn on the variable scaling, even though we've connected the output. Then the maximum size variation is going to control how much, or the overall scale based on this variable scaling. Because right now, if we populate it, there probably won't be any scale changes, just because the maximum size variation is 0. Although it does look like maybe that is working correctly, because it's probably, it looks like what it's doing. So if the maximum size variation is set to 0, it is going to subtract using the variable scaling, which is actually exactly what I wanted. So that way we can set it to 0 and then have smaller instances. In some cases, black might be too low, which can cause objects to be too small and you won't see them at all. Let's just take a look at a render and see how that's turning out. And that looks like it's working pretty good. Because I added that offset to the elevation, and since it's not really all that variable based on the instance itself, because they're not centered, may need to remove that in order to get the smaller instances to show properly. For the most part, it looks like it's working really well. And just one last note, and it has to do with the source image sizes for these controls. So basically that altitude and slope that was created. Now, my scale is a little bit bigger than the object itself. In other words, I have more pixels than I do polygons. So if you're noticing any finely detailed areas, or just some areas don't really seem to match up, it's mostly going to show up with details that are basically too small for the geometry, but still showed up in the render. And even though we use the source geometry for the image, the interpolation of the image itself and the way the pixels work rather than the way polygons work, it might be a little bit off. So what you can do to make sure that everything really carries over quite well is if we take a look at the scale of our object, the original dirt, it's 600 by 600. So what you would want to make sure you do is to scale the image to be 600 pixels by 600 pixels. Now that scaling process, depending on the program you're using, is going to use an interpolation method which can modify the polygon. So you want to stick with, if you were using, say, Photoshop, you would want to use a bilinear mode, or you can re-render it so that you've got 600 pixels by 600. So if we take a look at this image, and this is our altitude, and then we adjust the image size, bring it down to 600. It does look like I cropped it in a little bit too much. So we'll just turn off constraint proportions. So I cropped out one set of pixels. But the way it's going to resample the image, bilinear should keep it pretty close to the original state. Because anytime you resize something and resample it, it's going to kind of shift things around. So it really depends on the detail. And this is really only if you're running into any major problems. So if you need to try different interpolation methods, you can. Smoother can work pretty well, the bicubic smoother. But bilinear seems to produce a more even result that's equal to the original image. At least I find it does. It also keeps edge pixels from being created, which the sharper modes can create. So I've gone ahead and added in the rock objects just so we can take a look at a render with the dirt. I removed the sphere object I had in there. What I'm going to do is go to the scaling and orientation, change the rotation to all axes. I'm going to set my maximum size variation to 0.1618. And then in my variable scaling and that image, I'm going to modify this connection here, adding, first I'm going to invert it. I want the smaller ones on the steeper slopes. Or actually, no, I do want it the other way around. So sorry, we're going to leave that the way it was. I'm going to add a filter, and I want to make sure that that black doesn't go all the way down to 0, or -1, basically, because -1 is going to create a scale that is basically so small you really can't see it, which will also create instances that are not needed, since they're not showing up. It's just going to hog resources. So what we can do is we can use a map filter if we want to stay within our gradient and keep the gradient, or if we want to just clip it, we can use a clip filter, and the default contrast to brightness 0 will work quite well, and what we can do is just take the lower clip and bring that up a bit. So that way, -1 is going to be basically a scale of 0. Really depending on the variability, it shows that it has a chance to reach that scale of 0. So we can just bring it up a bit, that lower clip, so that way we have a gray showing up rather than black. And then go ahead and we can populate it. I also want to note the direction from surface, as I see it here now, is another thing that really relies on the polygon geometry in order to change the direction from the surface it's facing, whether or not it's going to be vertical or perpendicular, and kind of lean on the sides of slopes. That slope map we created can be used to control direction from surface in order to emulate the controls that you would have with a polygonal surface rather than a plane. So those couple of image maps rendered out for the materials are really, really useful. So I'm going to go ahead and scale that, or increase the density. We're going to fill it in a lot and see how many instances we get. 162,000, we'll take a look at that. And I'm only previewing so many instances, so I can't really see all of them. Okay, so now what we're seeing happening is because I changed the overall scale variation amount, what's happening is we have really, really small instances on flat surfaces, and then rather large ones on the steeper slopes. And I want that to be a little closer to each other. So what we can do to even those out a little bit more is in the scaling and orientation. We're going to go to that lower clip and that clip filter, and we can just bring that in. Let's go ahead and do 0.5. And that should keep them from getting as small as they were. Okay, so that filled in really nicely. The scale change is there, so we have larger objects on the steeper slopes filling it in, but the top objects are not getting as small as they were, or at least the flat surface objects. If you do want to add a little more variability to it, since right now the scale change is really only effective within the slope range, what we can do is mix this together with a noise, just using a blender. We could do it before it's clipped in order to control our output a little easier. So we'll let's just add a noise node and decrease our scale. We'll go ahead and we can multiply. Actually, I think I'm going to just set it to subtract, and we'll just subtract from that. Set to about 0.61, and then the clip we can maybe bring down a little bit more. And that way we have a little more variable scale that's not just based on slope. And I'm going to go ahead and render this out to the picture viewer rather than the screen, so that I can use a filter and just lighten up the gamma a bit. Okay, so it's looking a lot better. And you can see how much control we can really get just by using a flat surface. It's going to be really, really efficient for your memory. Saving files should be a lot faster. Obviously, it'll keep down the scene size because you don't need to create duplicates of higher res objects. I do want to note it will save, or it should save the textures with the carbon scatter file. But now in this case, if I wanted to take this and bring it into my other scene, this distribution, what I can do, although the population itself is non-transferable, if we go into the function editor, we can just save the entire function, or individual channels by going into the material editor, right-click, save function. That way we can save an individual function, even if it's something that can't be saved in that way, like the offset from the surface. We could temporarily connect that to, say, the density to save it. But if you want to save out all of these channel outputs, and including the links to all the images, you just go down on the right and you can save that out as a function file, so the FNC file. Now I also want to note, I do personally like to turn off compress file. It takes longer to save the compressed files and sometimes longer to load them in, and typically most functions don't get very large in size by themselves, so I like to keep the file just full size instead of compressing it, and try to save more compatibility when future releases of Carbon Scatter come out, just because I know that in the past with Vue, there can sometimes be compatibility issues between versions when compression is used. It's a little bit easier to keep things working properly. So now we can go into that other scene and load in the density for a plane and set that up. The only thing you need to do is repopulate that list, since that's not something that could be saved.